Okay, may I take this opportunity to welcome you to today's lecture, where we are still going to look at the structure of matter, that is under lecture 2, and specifically look at the specification of atoms. So under specification of atoms, we know that each element is normally characterized by its basic constituents, that is the atom itself. And an atom of an element is normally specified by X, superscript A and subscript Z, whereby the X itself, normally the X itself stands for the chemical symbol. Of course, the chemical symbol for the element. And then A is the mass number, of course. So when we talk of the mass number, we are talking about the sum of the protons and the neutrons within the nucleus. And then we have the Z that refers to the atomic number, that is the number of protons within the nucleus. And then we have the number of neutrons in the nucleus, which can be given by A, which is the mass number, minus Z, which is the atomic number. So that one has been illustrated in this image where we have Z as the atomic number and indicate the number of protons, and also we have the mass number that is indicated that indicates the number of protons plus the neutrons, the chemical symbols species. So here we have X, A represent the number of protons and the neutrons, and then we have Z that represent the number of protons. Of course, we also have the number of neutrons, which we can get by simply subtracting the atomic number from the mass number. An example is whereby we have chlorine 35 with the atomic number of 17. So we have the atomic number 17, we have the mass number to be 35. So we can subtract the atomic number from the mass number so that we end up with 18 neutrons. So the number of neutrons that can be calculated by simply subtracting the so known as atomic number from the mass number. So this should be atomic number from the mass number. So there we have carbon 12. Look at the carbon 12 itself. We have the 6 protons, of course, and we have the 6 neutrons, which give us a total mass of 12. So the mass number is 12, the atomic number is 6, which is the number of protons. So if I want the neutrons, I simply take 12 minus 6, I still get 6. Same to calcium, which has got a mass number of 40 and the atomic number of 20. So it means that it has got around 20 neutrons and it has protons 20. So the mass number is 40. Of course, examples, we can have several examples like carbon 12, the calcium, which is a mass of 40. We have the technetium that has got a mass number of 99 and the atomic number 43. Of course, if you subtract this, you're gonna get around 56 number of neutrons. Same to calcium, you get 40 minus 10, you get 20 number of neutrons. And also we have the carbon 12 minus 6, you get 6, which I've also talked about. Okay, we've just come to the end of the lecture for that introduction, which was a bit short. So may I take this opportunity to welcome you to the third lecture, in which within the third lecture we'll talk about the classification of atoms, where we're going to classify our atoms based on isotopes, isotones, isobars, and also isomers. We're going to look at what are the isotopes, and also look at what are the isotones, and also what are the isobars, and what are isomers. So if you have any question, please, you're free. You can just leave it down there by the chat, and I'll always respond to the comments. So just comment on the comment sections, just leave your question, and then I'll have to tackle it. Otherwise, thank you so much, and have your questions at the comments. Thank you.